Welcome. Today we are diving into Domain 4, Information Systems Operations. Specifically, we will master systems availability and capacity management. These are the twin engines that ensure IT services are not only up and running, but can handle the workload demanded by the business. Without these controls, systems crash, revenue is lost, and SLAs are breached. Let's begin. Let's start by defining our scope. In the world of IS operations, we look at systems performance management. This is the umbrella term covering two critical areas, availability and capacity. As noted in your study guides, the primary goal here is to ensure that IT systems have the ability to meet business objectives. It's not just about keeping the lights on, it's about resource allocation. Management is responsible for allocating labor, technology, and budget. If we fail here, we face business interruption. As auditors, we look for documented processes. If it isn't documented and approved by management, it's not a controlled operation. This diagram illustrates the flow of authority. We start with business objectives. At the top, IT exists to serve the business. This drives IT governance, which mandates performance management. Notice how this splits into two streams. Availability, is it on? And capacity, is it big enough? Both streams converge to deliver on service level targets. If either stream fails, the target is missed. Now, let's zoom in on capacity management. This is about physics and math. Do we have enough CPU, RAM, and disk space? As cited in the text, capacity management ensures performance falls within an acceptable range specified in the service level agreements, or SLAs. It is critical to understand that capacity issues often disguise themselves as availability issues. If a server is 100% busy, it looks down to the user because it can't respond. Therefore, we must monitor utilization metrics like CPU speed and storage space. As an auditor, you want to see that they aren't just reacting to crashes, but monitoring thresholds to prevent them. Monitoring is about the now, but capacity planning is about the future. You must review periodic measurements to identify trends. If the business plans to acquire a competitor next year, IT must model that workload now. We look at two types of scaling. Vertical scaling means buying a bigger server. Horizontal scaling, often used in cloud computing, means adding more servers to a cluster. In modern cloud environments, we look for elasticity, the ability to automatically scale up and down to optimize costs. An IS auditor evaluates if these forecasts align with the strategic budget. This state diagram shows the continuous cycle of planning. We start by monitoring usage. We analyze trends. Are we growing? We forecast demand. Then we hit the gap analysis. If we predict a deficit, we must provision resources, buy hardware, or allocate cloud storage. If capacity is okay, we return to monitoring. This loop ensures we never hit a wall. How do we measure success? Through service level management. The core document here is the SLA. As the source text states, an SLA must define measurable commitments, such as response times or uptime percentages. It is the bridge between IT and the business. If IT operations fail to manage capacity, they violate the SLA. As an auditor, you must verify that SLAs exist and that they are written in non-technical terms the business understands. You also need to check if they include the right to audit clause, especially with third-party vendors. Here we see the relationship structure. The business unit demands specific service levels. The IT provider commits to them via the SLA class, which contains attributes like uptime targets and penalties. To fulfill this contract, the IT provider relies on two internal methods: availability management and capacity management. You cannot manage what you do not measure. System monitoring provides the eyes and ears of operations. We use network analyzers to peer into traffic and find bottlenecks. We generate utilization reports to see if our CPU is redlining. We also rely heavily on log management. In large environments, human review is impossible, so we use EM, Security Information and Event Management Systems, to correlate events. If an auditor asks, "How do you know the server is up?" the answer should be an automated availability report, not because nobody called to complain. This mind map breaks down the monitoring ecosystem. On the network branch, we watch bandwidth and latency. On the server branch, we watch CPU and disk I/O. In the log branch, we capture errors and security events. All of these feed into the outcomes, generating alerts for immediate action, trend analysis for planning, and SLA reporting for governance. Availability is achieved through resiliency. We want systems that don't die when a component fails. This is called fault tolerance. We achieve this through clustering, grouping servers together. In an active-active cluster, everyone works. In active-passive, one waits for a failure. We also use load balancing to spread the traffic evenly. The enemy of availability is the single point of failure, or SPOF. If you have two servers but only one network cable, that cable is a SPOF. As auditors, we look for redundancy at every layer: power, network, and storage. This flow shows a resilient architecture. Traffic hits the load balancer, which distributes it across servers 1, 2, and 3. If server 1 dies, the load balancer instantly shifts traffic to 2 and 3. These servers connect to a clustered database. Even the database replicates to a standby DB. This design eliminates single points of failure. A critical component of availability is the hard drive. We use RAID, redundant array of independent disks, to protect against drive failure. You need to know the differences. RAID 0 is striping it's fast, but has 0 redundancy. If one drive fails, you lose everything. Never use RAID 0 for critical systems. RAID 1 is mirroring writing the same data to 2 disks. It's safe but expensive, because you lose half your storage capacity. RAID 5 uses parity to survive a single drive failure with better storage efficiency. RAID 10 gives us the best of both worlds, speed and redundancy, but at a higher cost. Auditors check RAID configurations to ensure they match the data criticality. Here we compare RAID 1 and RAID 0. On the left, green. RAID 1 writes the full data to disk A and a full copy to disk B. If A fails, B works. On the right, red. RAID 0 splits the data. Part 1 goes to disk C, Part 2 to disk D. If disk C fails, you only have half the file, which is useless. The diagram visually proves why RAID 1 is redundant and RAID 0 is not. Finally, how do we audit this? Our objective is to determine if these controls effectively support the organization. We review the KPIs. Are they reporting the truth about uptime? We check the capacity forecasts. Did they predict the storage shortage, or was it a surprise? We physically or logically inspect configurations. Does the server actually have RAID 5 enabled, or is it just in the policy? And we review operational logs to ensure that exceptions like failed backups or high temp alarms were acted upon. The auditor provides the assurance that the availability and capacity claims are real. In this audit sequence, the auditor starts by requesting capacity reports from the IT manager. The manager provides the paperwork. However, the auditor validates this by checking the system logs directly. If the logs show thresholds were breached, the auditor interviews the manager about corrective actions. Finally, the auditor documents the findings, comparing the manual reports against the system evidence.